So good afternoon, everyone, and welcome to our MSCC technical webinar, Containers on the OSPool. This webinar is the first iteration of a larger technical webinar series that we'll be hosting, and we're pleased to bring this opportunity to the community and share this information. I want to note that any materials and the recording from today will be shared with you after today's session. Again, today's session is Containers on the OSPool. It's offered in partnership with Swarthmore College and the Research Computing at Smaller Institutions community. We're joined by Dr. Andrew Owen. Again, want to note that this webinar is being recorded, and to get us started, I would like to just briefly introduce our speaker and presenter today, Andrew. Andrew Owen has been a research computing facilitator for the OSPool and Open Science Data Federation for 3 years, based out of the Center for High Throughput Computing at the University of Wisconsin-Madison. He's helped numerous users deploy their software in container environments, from writing guides, creating example recipes, to troubleshooting difficult builds. Prior to CHTC, he received his Ph.D. in chemistry from the University of Wisconsin-Madison, where he applied and developed quantum mechanical methods in the study of small molecules of astrochemical interest. He collaborates with his research group in his spare time, developing open source programs and continued support of the research. So with that, I'd like to pass it to Andrew to lead today's webinar. Thank you all for joining us.
All right. Good afternoon, folks. Hopefully everyone can hear me. All right. My name is Andrew Owen. I am a facilitator at the University of Wisconsin-Madison. I'm going to go ahead and share my slides here. Maybe. Here we go. So I'm a facilitator with the Center for High Throughput Computing, CHTC, at the University of Wisconsin-Madison. And I'm going to be talking to you today about containers. I'm going to talk a little bit about the OSPool, which is what my job description is for. So you get to hear a little plug for that as well, and hopefully that is interesting for most folks. Okay, so the big picture that we're coming with from the OSPool is that we don't want computing, or rather the access to computing, to be a barrier to research. So if you're a researcher who needs computing power, we want to help you overcome that barrier. And a lot of times this comes down to asking, what if? What if you could do your calculation 10,000 times in the time it takes you to do a couple of them? So these are some past researchers on the OSPool. What if you could measure not just one plant, but hundreds? What if you could experiment with processing 100,000 images at no cost? So the OSPool is a nationwide system with dozens of participating institutions across the country. Most of this computing capacity is opportunistic. That is when, a lot of these places have their own computing clusters. They've spent a lot of money to get those servers online, and they want to make sure they're always running, they're always doing science. And when those machines are idle, these participating institutions allow the OSPool to run calculations on that idle hardware so that it can be used to support science across the nation. I'll talk a bit more about that towards the end of the presentation. But for now, I think it's worth highlighting, why do we care about containers? And this is a problem not just with the OSPool, but really any time you are transitioning, or a researcher is transitioning from their computer to a shared computing system, right? Whether it's the OSPool, whether it's a local HPC cluster, or one of the larger national labs, there is this transition from doing research on your own computer versus doing research on a shared computing cluster. And I like to think that there's usually two main barriers to go through this transition. The first is just sort of a conceptual one, which is learning how does that shared computing system work? Whether that's how you log in and submit jobs, or just what is the organizational principle for getting access. But in my experience, the other technical barrier is software. The researcher has been working with a certain set of software on their own computer. That's why they've been developing their project, making their code, doing their science, and now they need to scale up for some reason. And to do so, they want to keep using that same software, right? That's what they've been working with. And ideally, they just want to be able to pick that up and stick it on whatever system they're transitioning to. And in general, with shared clusters, this becomes a bit of a problem because the user doesn't have admin permissions. They may or may not have direct access to the machine that's actually going to be running their calculation. And it's almost certainly going to have different hardware, different operating systems with different libraries and packages than whatever it is that they're running on their own machine. On the OSPool, we even have this issue going from site to sites. One day your calculation may run out in San Diego with a certain set of machines in a cluster. The next day it might run out in New York or somewhere else, again, with a different set of hardware and operating systems. So this is providing a challenge to the user. And what they really want to be able to do is get their software and operating system and whatever else it is they need. They want to get that on the system. Ideally, it's a one-time setup. They don't want to have to constantly be upgrading or, they don't want to have to install their software from scratch at the start of the calculation because it's a new machine. And they want to be able to use it anywhere. And ideally, the less that we can include the admins in this loop, in this ability to deploy the software, the more efficient it is for the user. There's less back and forth time, with emails or office hours. And if you have a small team on your local cluster, I mean, maybe the admin is already stretched thin, just trying to make sure the machines are online. They don't have the time to install this version of software from one researcher and another version of a different software for another researcher. And this is where the container technology comes in. So containers are, I hope I'll demonstrate today that containers are a pretty powerful way of satisfying most of these requirements to help overcome those barriers I was talking about on the previous slides. Now, something to know is that this isn't a magic cure. It's not going to be the solution for every scenario. But in my experience, it's a pretty powerful tool that gets you, or at least helps most users with the type of work that they want to do. So to help explore that, demonstrate that, I do have some hands-on exercises for us to work through today, and that's what the majority of my presentation is going to be on. To get set up with these hands-on exercises, you can log into our guest notebook interface. So this is a service that we provide through the OSPool, and this will let us have a consistent environments already set up, ready to go with the exercises that we want to use. You did not have to sign up in advance in order to get access to this service. We are connected with the In-Common Federation through CI Logon. So if your institution is connected through CI Logon through In-Common Federation, you should be able to log in just fine. Excuse me. So once you log in, select the guest account option. Most folks are probably, that's the only option that will appear. But if you already have an OSPool account, you may see an option for AP40. I still want you to click on the guest account just to make sure we all have a consistent experience with these exercises. Then click start, and within hopefully a minute or two, the Jupyter interface will start up and we'll be able to start working through the exercises here. Let's see, and I also have the materials on a GitHub repository. This also includes a link to the slides and a link to these things. So I'm going to use this. I'm going to drop both the GitHub repository and the slides in the chat here, so that if you get lost while I'm working on stuff, you can still find the resources you need to get up and running. If you aren't able to log in for some reason, maybe your institution isn't in the Federation, or some other reason you don't have your phone with you to do two-factor, that's fine. Just follow along. As Jessica mentioned, this is being recorded as well. So, with the materials provided afterwards, you're welcome to replay all of this and go through the hands-on exercises once you're set up.
I tried to log in, but it's saying it's giving me 403 forbidden access.
That's a new one to me. I'm not sure how to help with that, unfortunately.
It's
So,
okay.
yeah, for now, I'd say just follow along with the presentation, and hopefully you'll still get some good information out of it. All right, so I'm going to the OSG HTC notebook service here in my browser, and I see a prompt here to sign in with CI logon. So I'm going to click on that. And like I said, we're connected with the CI logon in Common Federation here. And this may suggest automatically like ORCID or something like that. Just click on that box and you can search through for your particular institution. So for example, I'm at University of Wisconsin-Madison, so I'm going to type in Madison. I got a couple options here. I'm going to click on university since that's where I'm based out of. I recommend the first couple times you do this, you don't hit remember me just in case you pick the wrong one. But I'm going to log in. I've already signed in this browser with my university ID, so it remembered that and it skips through my university sign in. If you haven't signed in yet with your institutional ID, you'll be prompted to log in. And if you're like our institution, you'll have to do a two-factor authentication in order to confirm that you are who you say you are. So once that loads, you should see something that looks like this. And like I said, because I have an OSPool account, I have this option for AP40. If you see this, ignore it. We still want to use the guest account option here in order to connect to this interface. So I'm going to start that up. We'll see something like here. We do here. So this is behind the scenes. We're starting up a server that has this standard compute environment set up. Normally we use this for test driving the OSPool. So if you're interested in learning more about the OSPool, this is a great interface to try it out without having to sign up in advance or anything like that, as long as you're part of your institutions in that common federation. So here we see the Jupyter Lab interface. In the middle, we have a launcher. We're going to ignore that for now. On the left-hand side, we have a file navigation menu. And what we want to click on is this tutorial-containers. That's where we want to go. So tutorial-containers, we've already preloaded the exercises into the system here. And we want to open up this tutorial-containers IPYNB file. This is a Jupyter Notebook file, and it already has the exercises that we want set up in here. I'm going to close that launcher tab because I'm not going to need that throughout this. So this is a Jupyter Notebook interface, and what I want to cover is mostly in here. I do have a few more slides to wrap up at the end here, but for the most part, what I want to cover is in this mode here. I believe there is a presentation mode to make the text a little bit bigger, so I'm going to turn that on. You certainly don't have to. Okay, so setup, we've already done this, so you can exit the recursive loop at this point. You don't need to repeat these steps. Materials are linked through here. This is also in the GitHub page as well, and that'll be available after all of this. And before we get too far in the weeds here, I do want to just state a disclaimer. This is basically my cumulative experience about working with containers. And I don't have a background in computer science. I'm not a professional programmer, and I'm not a developer of container technologies. So what I'm presenting is my mental model. I think it's a pretty good mental model, but I do not claim that it is perfectly accurate. If there's anything that you think I should be corrected on, please let me know. I'm happy to update my mental model with someone who's got more experience than me. Okay, so quick starts. First, I just want to demonstrate the utility of containers. And this is going to be a pretty simple toy example. We'll do a little bit more involved one later on after I've explained some of the pieces. But I'm hoping that this will illustrate sort of what we're doing here and why we even bother with this technology in the first place. So let's start with a simple version of our scenario, which is I need Python 3.10. I need to do research, whatever scripts or program I'm running, I need Python 3.10. I don't care about anything else. Give me Python 3.10. So we're in this notebook interface with Jupyter notebooks. In the code cells, you can run them on the service and they will execute. And then if there's any results that are printed or any files generated, that will happen. In this case, we have this code block, Python 3 -- version. I want to check the version that I have inside of this notebook environment. And to run a code block, I can hit the play button up here. But it's usually more efficient to use the keyboard shortcut. So the keyboard shortcut is Shift and Enter when you have that cell, that code block highlighted. If you ever forget what that shortcut is, you can just hover your mouse over the play button. You can see that help text states it there as well. So I have this code block. I'm going to do Shift Enter to run it. That executes the command, prints any output into the notebook interface. If I were to mess with any files, you would see the updates on the side. And here what we see is that in this notebook environment, we are using Python 3 13. So major version 3, minor version 13. But like I said, for my hypothetical research, I need Python 3.10. Python 3.13 is not going to work. It introduced a new feature that breaks my code, whatever that may be. I need to use Python 3.10. So this is where we're going to use a container to get us that software. So we're going to run a command here. For now, don't worry about too much about what we're doing. All you should take away from this is that we are creating the container with the software we want to use. So I'm going to go ahead and run that. So the progress bars that Apptainer spits out does not work nicely with Jupyter. So if your screen is filling up, you should be able to click on the left side of the outputs to expand or collapse the output. So if I were to expand that, we can see it's going on forever. I'm just going to click on that left side to collapse it. Now it's down, it's got a scroll bar for viewing it. So we see some progress bars. Again, we're going to talk about what's going on here in a minute. There's more progress bars. Don't believe the time estimates. The cake is a lie. Just keep on going. And this should finish up in another 20 to 30 seconds. So fun working with progress bars. Okay. What we have down here is build complete. It's created this file. If you were looking at the command, we see that is the file name that we provided in our commands here. And I provided some other instruction that includes the words Python and 3.10. So hopefully that's a clue that whatever we're doing here, we're getting Python 3.10 in some fashion. On our left-hand side, we now have Python 3.10.sif. So this is the file that we just created by running that command. Like I said, I'll explain what this is more as we go along. But for right now, you can think about this as being the software environment. This .sif file has the software that we want to use. And now all we need to do is use it to access that software that we set up here. So that's what we're going to do in this next step. I'm going to access this software environment from this new file that I created. And that's what this command is doing. At the end, I'm passing in that same command that I ran earlier to check the Python version. And if I run that, what I'm going to see is Python 3.10. Okay, so cool. Earlier we had Python 3 -- version. It gave us Python 3.13. That's great if my program uses 3.13, but it's a problem if I need 3.10. After some mysterious black box action, I got a new file, and when I used that file and I executed this Python 3 version command inside of it, I see a different version of Python. So some things to note about this process. You did not install Python 3.10 in this notebook. Instead, you created a file that has access to the files that make up everything that is Python 3.10. Someone already figured out how to get those into this file, and we just sort of grabbed it. And now we have access to Python 3.10. You didn't remove Python 3.13 from the notebook. If you go back and rerun the initial Python version commands without this special stuff that we just went through, you're going to still see Python 3.13. And what's really nice about this file that we created is that we can download this or ship it off to another computer And we have access to that software on that other computer as well. Now we'll need to have the corresponding container technology installed. And today we're going to be focusing on Apptainer, which is an open source technology. But in principle, anywhere I have Apptainer installed, I can ship this file and then run this exact same command, and I'm going to get the exact same output that I saw here. So this is a portable, reproducible software environment. And while we didn't see it in this quick start example, you can control the software that goes in here. In this case, I happened to choose something that I knew already had Python 3.10 in it, but I could have created it from scratch to have whatever version Python I wanted with whatever compile options set up that I wanted. I could have gone into more detail and got more control in my software environment. Okay, so that's the quick start. Hopefully that gives you a taste of what we can accomplish here using the container technologies. But before we get into too much more detail about how do we actually use this in practice, I think it's important to cover just a few core concepts that I think helps clarify what you're doing and how we work with containers, because these can cause confusion for users when they're getting into these weeds. So I'm going to start with an analogy from movies. I think this is a pretty strong analogy, and I have a word-by-word breakdown of the exact comparisons here. But when you think about what is a movie, it's a sequence of images and sounds that are displayed over time, and you observe them, you absorb them, and they tell some sort of story through your senses. Now, that experience can only be triggered when you hit play. And when you hit play, what you're doing is you're reading some data off of a physical storage medium, right? This could be a DVD, this could be a Blu-ray, this could be YouTube, right? You could be watching something in your browser. And there's some data on a disk somewhere that when you hit play, it generates this sequence of events that you can experience. Now, to get that data, to get that sequence of events onto a physical media somewhere, there is a process of recording and editing and things like that. And usually, you don't go into this expensive, difficult process willy-nilly. You usually have a plan to start with. Someone writes a script. Someone has a list of the costumes and the scenes and the dialogue and who the characters are and all of these details that eventually, once recorded onto that data, become that experience when you play it out. In the same way, we can think about this with containers. The container itself is actually the interactive software environments that you can execute commands inside of. This is the part that you play with. This is the part that you experience. But in order to get in that interactive environment, you've got to hit play. You've got to run it. So you've got to launch it. You've got to initiate that interactive experience. And where it's coming from is there is data on a disk somewhere. And we refer to this as the container image. And the container image has that data recorded in it that says what the interactive software is and what the settings are for this interactive environment. Of course, to get this on a disk somewhere, you've got to create it, right? There's this process of generating it and then recording it, saving it into a file, and that's the build process. And just like with a movie, it's good to have a script for what you want to create. There's instructions that you provide that tell the container technology how it should construct, what it should construct and include in this container image in order to recreate your interactive environment. So I have a point-by-point breakdown. If you're still not comfortable with that analogy, hopefully that will help fill it out some more. One thing that I'll emphasize here in this note is that just like a movie in the common parlance can refer to both the experience of watching a movie and the physical media that contains that experience in record. In the same way, in common parlance, folks will refer to a container or use the word container to refer both to that interactive experience as well as that physical data on disk that is used to create that interactive experience. So which one you use is probably not super important, and you'll hear me use both, sort of interchangeably use container in this way. But I think is worth highlighting for someone who's has close attention to detail that could cause confusion. Okay, so that's sort of what we're doing with a container, or in terms of where we need to start and how we get to the ends. It's worth going into a little bit more detail about that. Just, if you're someone who's trying to do this, or you're someone who's trying to teach this to someone, it can feel very overwhelming. So having just a point-by-point walkthrough of how to go through it is a useful guide. And before we jump into that, I do want to emphasize, if there's two things I want you to take away from today. One is don't let compute be a barrier to your research. And the other is deploying your software in a container is no more difficult than any other method of deploying your software on a shared computing system. And I think this is important to emphasize because there's a common sense that containers are complicated, containers are difficult, containers are for someone who's got a degree in computer science, or that, way in the server weeds DevOps guy who is a pro at GitHub and whatever else. Containers are too complicated. But in my 3 years of experience, and I'm sure my colleague Christina can attest to even more experience than that, is that installing software is hard, period, regardless of how you go about it. But with containers, you get additional advantages that you don't get with other methods of deploying your software. And the points I'll highlight again, it's reproducible. You get control over what you want to have in it. And the deployments is independent of the host operating system. So every other method of deploying software, if someone upgrades the operating system at the cluster, you've got to repeat your software installation. You've got to repeat your software setup. But with a container, it doesn't care about that. Unless there are very drastic changes to the computing system, it shouldn't matter what version or what operating system your cluster is running on. You should still be able to use that same container image as before to get your software environment. So there's 3 phases to the process of working with containers. Phase 1 is setup, which is just making a plan, essentially making that script. Second phase is build. This is creating that container image, recording that movie. And like with recording the movie, there's going to be some back and forth with the editors and the producer. They all happen to be in your own head, but that's neither here nor there. And then phase 3 is actually using it. It's mailing out a Blu-ray disc for other people to watch your movie that you put a lot of time and energy in. In theory, just like with a movie, once you've got through the first 2 phases, then you can just keep generating Blu-rays. You can just keep sending out Blu-rays, and you won't have to go back through phase 1 and 2. You can use the container however many times you want without having to worry about, the host operating system and things like that. So first up in setup, you need to identify the main software you want to deploy. And actually, you should be identifying all the software that you need to deploy and their dependencies. But in general, if you focus on what the main software is, that sort of makes the rest of it sort of flow out of a logic tree, right? It just comes inherently. The main thing you want to get. If you can get that, then that's, what do you need to get that? And you can keep working backwards from there. Look up the installation instructions for that software, and are there additional programs required? Sometimes it's not a hard dependency, it's a soft dependency. It's an optional thing that you need to have. And keep an eye out for if you can install your software through some major platform like Conda or PyPI or something like that. Third point here is to find a good starting point. You don't want to reinvent the wheel every time you build a container. Containers can be tricky sometimes to get set up, but a lot of people have already figured that out and published containers that will give you maybe not everything that you need, but it gives you most of what you need. And a good rule I found is to decide, what is the most hard to install software in your requirements. That's what the container you choose as your starting point should already have that set up. So whatever you think is going to be the biggest headache, see if you can find a container that already has it sorted out for you, and that can give you a good stepping stone moving forward. And something to note along these lines, especially with the identifying the main software, some developers publish official containers, images for their software. And in fact, that's what we were using up above. We were using an official Python 3 container in that quick start. So, if you know the main software you want to use, check out their documentation, check out their GitHub. They already may have if not a full container image, they may have the recipe for creating a container image. And they have an intimate knowledge of their software. And so hopefully they understand how to deploy it. And you can just use what they've already figured out. Phase 2, of course, is to go from that planning phase into actually creating the container image. And something I want to emphasize here is that, phase 1, feel free to just get a first draft. So you do not have to get phase 1 perfect before moving on to phase 2. Just get a rough draft of what it is you want to do and then start building on it, because, the well-laid plans of mice and men and all that is definitely going to come up with containers. So you need to create a definition file. This is your scripts for your movie, and it's going to contain the installation commands for setting up the software that you want to install, you want to be able to use in this interactive environment. And then there's the process of taking that script and recording the movie, filming the movie. So you build the container image, and we actually did that in the quick start as well. Our script was basically use someone else's container image. And then test, you want to review it. You want to make sure things look the way you thought it looked on camera, looks the same on the screen. So, making sure that software that you installed actually works inside this interactive environment. And just because it creates a container image doesn't mean it necessarily installed correctly the software you want to use. And then phase 3 is using it. And that is pretty simple 2 steps, which is you need to get the file, that data on disk, where you want to use it, and then you use it. You launch that interactive environment for interacting with your software. Okay, so this is sort of the roadmap here for working containers, but let's get a little bit more hands-on again, see what this looks like in a more realistic scenario. So I've set up something a little bit more realistic. It still needs Python 3.10. We won't go too crazy here, but you're a researcher, you found a GitHub repository, or you were handed a GitHub repository by your advisor, and they said, go run this. And you're like, okay, great. What do I need? I look at the README in GitHub and it says, I need Python version 3.10. It also says I need NumPy version 1.26 and I need SciPy. Cool, all right. They told me what I need. And they even included some instructions here about how to install it. But when I copied and pasted those on my cluster, I got a scary message, it asked me for a password, and then I didn't get it right, and it gave me a scary message that it's been logged and the admin's been notified. Oh no, what did I do? In addition, you also want Seaborn. And you don't necessarily even know what NumPy and SciPy are. You just know that you need it for the scripts. So how do you proceed here? So we're going to use container technologies to approach this. There's other ways of deploying Python software, but containers are more generalizable than those other methods. So first is what do you need? Making that list of what it is that you need. And in this scenario, Python 3.10, and then the Python package is NumPy. I need version 1.26, and I need SciPy, and I want Seaborn. Implicit here is also I need whatever scripts were in this GitHub repository. We're going to ignore that for now. We'll talk about it after we go through some more hands-on exercises. But in principle, yeah, we do also need to include the GitHub repository in there, but hopefully that's just, I need to move some files around. Installation instructions. I'm not super familiar with Python, but I know that if it's a Python package, I should be able to run this Python pip install command to get whatever those packages are. All I need is Python. As long as I have Python, I know I can run this command to get my other packages. So what that means for us is the main thing we need to install, or the main thing we should focus on, is getting Python 310 deployed. All right, so how do we do that? You could install it from scratch, but like I said earlier, you don't want to reinvent the wheel. You don't want to figure out how to compile Python from scratch in a container. That is, I haven't even tried that. I recommend you don't. It is certainly possible. It just gets more tricky and more complicated the older version it is. Now, this is where choosing a good starting point can save you a lot of time. Finding the container that already has Python 3.10 installed will save you a lot of time here. And I have a whole section at the end of this document, it's in the second appendix, about finding container images. There's a whole art and science that goes into it. It's just like finding any software on the internet. You've got to trust your sources and things like that. The TLDR here, the too long didn't read, is that we're going to use this Docker Python 3.10. This is an official public image that we're going to use as the base image, the starting point for this build. It's what we used earlier on, but we're going to just use it again here in this next step. Okay, so then we need to write the definition file. So the definition file is your scripts for how we're going to record this movie that becomes our container image. And we're focusing on the Apptainer technology today. This is an open source technology designed for shared computing systems. I believe it is more beginner friendly than other container technologies, so that's a nice bonus as well. And with Apptainer, it is a script. So there's some front matter at the top, but then you just add in the commands that you want to run. So in this case, the commands we want to run is this particular Python pip install commands. The other stuff that we have in here, so this bootstrap, I won't go into details about what that means, but the short version is that we did it again. The short version is that we are starting from another container technology called Docker, which has a really good distribution platform called Docker Hub. And from that, we want to choose this Python 3.10 image as our starting point. We're saying this is my starting point. And once I get that starting point set up on my local device, in the post section, I want you to run whatever commands I list here. So that's a short version of the definition file. There's a lot more details in here. I wrote up a pretty good guide for our local system for CHTC. You can check that out. And of course, feel free to check out the Apptainer manual as well. So let's just confirm that my file is in there. Again, to run a code cell, you can do Shift-Enter. Oh, no. Oh, right. I didn't provide it. We have to create it. Okay. So I didn't create it yet. If I look in my left-hand side, there is no mycontainer.def file, so I need to create that. So in the menu, you can go up to File, New text file. You can also right-click to get the new file option. I'm going to replace the entire name with my-container.def, hit enter to confirm the file name. So this touches the file. And then I can double click on this in the file navigation pane to open it up in the Jupyter interface. I need to copy the contents I want to use. So copy, switch back to the file, paste in. The little filled in circle in the tab there says it's not saved, so I need to save this. I can, go up to save file, or I could use the Control-S shortcut. And now I have this definition file has been created. If you want it, you can add in other Python packages. Just be aware I haven't tested it, so there's no guarantee it'll work. But in principle, you can play around with this in whatever sense you want to get the Python packages you want. So let's run the cat command again. And now we see, yes, this is what I pasted in there, copied from above. Great. And that's why I added that code cell there to make sure I didn't miss an important step. Okay, so we've written the script for a movie. Now we need to record the film. We need to put it onto a storage device. And so to do this with Apptainer, we use the command Apptainer build. The first argument is the name we want our container image to take. And then the second argument is the instructions for how to build it. In the quick start, we just gave the source container name, and essentially we just skipped the post section. But in this case, we want to add some Python packages. So I'm giving it my definition file with that instruction to pip install the Python packages. So I'm going to run that. Again, we're going to see a decent number of progress bars, and that's just, it doesn't render right in Jupyter Notebooks. But now we're going to talk a little bit more about the steps that are going on here. So first set of progress bars that you see is it says fetching image. So this is downloading that base container from the internet, in this case, from Docker Hub, and it is extracting it into its interactive state. So it's downloading that interactive image, and then it's extracting it. And then it runs the commands that we put in the post section. So in this case, we had a Python 3 pip install. If you've ever pip installed a package, this should look pretty familiar. So we have, it's installing NumPy and SciPy and some other packages that are dependencies, that are requirements for those packages. And so if we keep scrolling through here, we see the usual Python outputs. When you're creating a container, you can ignore this warning about running pip as root. That's fine. We're creating a container. If you are the admin on a machine and you're running as root, you should definitely pay attention to this warning. You should avoid doing that. Okay, so it ran the commands in the post section, and now we get into this creating CIF file step. So it ran those installation commands inside of the interactive environments, and now it's going to save it. It's going to freeze it. It's going to record it onto disk. So that we can use it to create the full interactive environment we want to use at future points. And again, don't pay attention to these time estimates in the Apptainer progress bar. It is wildly wrong. I don't know why, but it usually takes maybe a minute or two, depending on how large of a container image you're creating, for it to complete. And then when you're done, you're going to see build complete at the end here. So it has created the SIF file, and in principle, it is ready to go. We can use that file now. So this text here is just in writing what I just said out loud, so I'm going to skip over it. And at the end here, we can run file mycontainer.cif, and we see, yes, we have this Singularity script executable. I won't go into details about why it says exactly that, but the answer is that, we have our container image. We are now ready. We've recorded the film. We're now ready to show it to our friends and try it out. So that leads us to phase 3, which is executing the container. And, earlier in my breakdown of phase 2 versus phase 3, I said phase 2, you have to do some testing. I'm not actually going to be distributing this, so testing it and using it are the same thing. But in principle, if you are planning to distribute your container image, whether that's through Docker Hub or GitHub, or just sending friends a Dropbox link or something like that, you should test it out, make sure that it works the way you expect it to. And that's what we're going to do here. So to run commands inside of that interactive environments, you can do Apptainer exec. That's actually what we did earlier on in the quick start. And this tells Apptainer to take that image name that we give it, take that container image, create that interactive environment, and then execute this specific commands. And when it's done, it can undo, it can close down that interactive environment where we're not going to use it again. There are ways to interact directly with it, and I'll talk about that in a minute. So Apptainer exec, we want to use this new container file that we created, and we want to check the versions of Python that we have inside the container. Now this looks a little scary, but the short version is that we're loading our packages and printing out the versions that they have. And so I'm going to run that now. This might take a few seconds for Python to launch up and execute. But here what we see is that we've got Python, we got NumPy package version 1.26. We explicitly told it to install that version, so it's good to see that it did install that version. And then we didn't care about the versions of SciPy and Seaborn. What we see here is versions 1.15 and 0.13. Okay. So this is a simple command to test, but maybe you've got a more involved test, or it's your actual full workflow. Then what you can do instead is just write a script put your commands that you want to use in that and then test it again. So when we look on the left-hand side here, I already included this python test.py file. You can double click it to open it up. It's a pretty simple Python code here. We import some packages, and we're going to print out some text and some versions here. So with Apptainer exec, I have Apptainer exec. So I want to launch and execute a command inside my container image. Here's my container image, and then everything that follows is the command, in this case, python3 test.py. So we're going to run that here, and this should hopefully work. Okay, it did. It executed. Here we see Python 3.10, NumPy 126, and the same versions of the packages that we printed out earlier. Now, something I want to emphasize here at this point, once you've got that container image, as long as you don't change it or mislabel it or something, then every single time you run this command in the future, you will get this exact same output. You're not repeating the installation command or anything like that when you run this. You are merely taking that saved interactive state that was recorded to image, and you're replaying it. And another thing I want to emphasize with this is that if you care about specific versions of your packages, then in your installation step, in that script that you write for your movie, you have to explicitly pin the version that you want to use. You have to explicitly state it. And this is worth emphasizing because usually if you don't specify the version, then when you do that build step, it'll pull whatever the latest compatible version is that will work with the rest of your environments. And you don't have the context for this, but I've been testing this material the last couple of days here as I've got prepared for this training. And when I was doing that, what I was seeing was that we were getting Python version 3.10.19. And so today, earlier when I ran this, it changed to 3.10.20. And so now, in my case, in most cases, the patch version doesn't matter too much. But if we had just said Python 3, then it's very possible that it could have installed Python 3 version 14 instead of Python 3.10. And the same applies to these other packages where we didn't provide an explicit version. Whenever I run this, I will get the latest compatible version. So I could get a jump from SciPy 1.15 to SciPy 2, assuming that's compatible with NumPy 1. There isn't a way to run commands interactively inside of your container environments, your active container environment. That's using the Apptainer shell command. You're welcome to try that out. So you just do Apptainer shell mycontainer.cif. This will log you in essentially into that container environment, and whatever commands you run will get parsed by that container environment. And something important to note here in the notebook service that we have, running code in the notebook and while the Apptainer shell is active in another tab, that doesn't work. So if you try this, make sure you enter exits before you switch back to running commands in the notebook. Otherwise, you're going to have a bad experience. But in general, anywhere you have this container file, whether it's in the notebook service or on your computer or on your local cluster, you could do Apptainer shell to activate it and run commands in it interactively. All right, so returning to a note that I mentioned earlier, which is, we do actually require our GitHub repository in order to run my program in that scenario, right? I have scripts in there that depend on Python 3.10 and NumPy 2, whatever. But I need my scripts from my GitHub repository. There's two places you can integrate them into your container environments. One is during the build phase when you build your container image. This option is for mature programs. So this is for scripts and programs that you don't plan on changing. And that if you have to change, you're fine with repeating the full build process, going through that Apptainer build command again. On the other hand, if you are actively developing something, then you don't want to include the scripts in the container image itself. Rather, You include whatever dependencies are required, your static dependencies for that code. You put that in the container image, but then the actual development code itself is something that you pull in when you launch the interactive container environment. And if you're submitting jobs on the OSPool, we do this automatically as part of the job submission process. You just have to list it as part of your transfer input files. If you are manually launching your container with an Apptainer exec command or something else, you should check out the first appendix, Appendix A, about how containers work with the host file system. It starts to get a little bit complicated then. Okay, I think I'm coming up on time here. I'm going to say first, OSPool has good support for Apptainer containers. The underlying software, HT Condor, also has good support for Docker, but most OSPool sites aren't running Docker. But we'll ship Apptainer with to our OSPool sites. I have an example of a simple job for using a container. So let's take a look at what's in there. You don't have to worry about all the details here. There's two things I want to highlight. First is we're telling it that we want to run this Python 3 command to run that test script that I set up earlier. And the other thing to note is that we have this line here about container underscore image. This is telling HT Condor that in this job, I want to use this container file as the software environment. And inside of that, we're going to execute our desired command. There's a whole lot of other details that go into submitting a job on the OSPool. And another thing that's worth mentioning is if you aren't in the guest option, then you do need to use something called the OSDF for shipping your container image around. But this is just a simple example to demonstrate that we're going to get the same thing that we saw earlier when we submit this job. So Condor submits the submit file. Again, this is, I'm not going to go into details about submitting the job. In the guest notebook interface, it should only take a few seconds to run. And when it does, we should see some output files on the side here. So with container.out, we take a look at that. And this should be exactly what we saw earlier when we ran the Apptainer exec command with that Python test script. Hopefully my error is empty. It is. That's always a good check to do. And just to confirm that this is what I saw earlier, I'm going to rerun my Apptainer exec commands, and there should be absolutely zero difference between these two. And I don't mean that they might have a different minor version. I mean, these should be exactly the same. This is a reproducible software environment, and as long as you don't change that SIF file, you should see no change in your results, assuming that you have a deterministic command that you're running and you're not doing, pseudo-random Monte Carlo or something. Okay, I'm getting up on time, so I'm going to breeze through the rest of this, but feel free to take a look, read in more about the notebook here. What I really want you to take away with the OSPool, we run an average of 1 million jobs a day. So if you're thinking about, oh man, I've got a 10,000 job workflow I need to run, and that's going to take a couple months on my laptop, think about the OSPool, because with the OSPool, once you get set up, those 10,000 calculations, instead of taking a couple months, could just be a couple of days. Your results may vary, but that's where I'm here to help out, and so do my colleagues with the OSPool facilitation team. OSDF is a data distribution system that we run, has caches all around the country. And the main thing is that when you pull data through the OSDF, it keeps a copy on one of these caches that are on the Internet 2 backbone. And the next time you request that item, it'll get the copy from the cache instead of going back to the original storage system. You can use the OSDF through the OSPool. If you are an OSPool user, you'll get space automatically, but you don't have to be a member of OSPool to use the OSDF, and I've got some guides linked in here talking more about it. On our documentation for OSPool, we do have some curated containers set up already, some of the more common softwares. So if you are using the OSPool, feel free to check that out, or if you just want a good starting point, these should be pretty good starting points for most people. Next steps, this is a very brief introduction, but in my experience, there's all sorts of things that can pop up that can go wrong with the container builds. And that's not necessarily a container problem, that's a software problem. And you won't realize what that is until you try to install your software that you want to use. So try and take these lessons, do a first draft of what your definition file is and give it a shot and see what goes wrong. I have a lot more information at the end of this document to help guide you along your way. If you have an OSPool account, we have some guides that you should check out about using containers on our system. If you don't have an OSPool account, but you've been sold on my sales pitch, you can request an account on our website. It only takes a couple minutes to request. If you want to use a container on your computer, you can do that. Apptainer works best on a Linux operating system. I haven't tried it on Windows and Mac. You could also use something like Docker instead. And there's some links here. If you want to use it on your local cluster, if you just want to use it on your own account, you can just follow those same set of instructions to install an unprivileged version of Apptainer on your user accounts. If you want to have everyone on the system use it, your system administrator should do the installation, and they should definitely read through the installation instructions for Apptainer. There are some security concerns with multi-user and shared computing systems that they should read up on. If you're using an HPC system, I want to put an important note here. Most containers should work out of the box if you're executing your calculation on a single node, one single node. If you want to execute your calculation across multiple nodes simultaneously on a high-performance cluster, then the software in the container has to be configured to work with your particular cluster's network hardware. That's a lot harder than it sounds, but it is possible. It just requires a lot of iteration to get that set up correctly. Feel free to reach out. I have some more stories I can tell you and hopefully give you some good advice. For help with OSPool or anything related from this training, feel free to send us an email, support@osghcc.org. We have twice weekly office hours for OSPool users. We also have monthly trainings. And if you're interested in connecting with the OSG, it's the parent organization that runs the OSPool. We have weekly campus meetups. These are targeted at folks who are either contributing or are interested in contributing to the OSPool. And you can email us for more information about that. And I'm going to jump to my slides to talk about the other things. Before I do that, just a quick inventory of what I have in the appendices. If you are launching the container manually and you're wondering how it works with the file system, I've got some sections here that cover that about how, and some hands-on exercises as well that you can run in this notebook to get a feel for how containers work with the file system. And then for building your own container, I've dumped a lot of additional knowledge here from finding container images. There's example definition files. I highly recommend you check that out. Troubleshooting errors, working with GPUs, working with different architectures, and you may be wondering about performance. So wrap it up in the slides here. OSPool, I really want you to take away here, the power from OSPool is not how big a calculation you can run, but how many calculations you can run. If you've got 10,000 calculations you need to run on your laptop, you should be thinking OSPool. Anyone who's based in the US as an academic, government, or nonprofit researcher can use the notebook, can request an account on the OSPool. You do not need to be a contributor to the OSPool in order to be able to use the OSPool. You can request an account through our website. It should be pretty easy to find. Couple of events this summer that I need to plug. HTC 26 is our yearly conference on high throughput computing. This is in June in Madison. We're still hammering out the schedule. The other one that I want to emphasize is the OSG school. This is a week-long summer school where we will teach you the concepts of high throughput computing and how to use the OSPool. You do need an application, and we do need a letter of recommendation with that application. So if you're interested in that, check out the website. Applications close March 20th. If we accept your application and you're outside of Madison, we will pay for your travel to come to Madison. And then facilitation team, we're here to help. There's myself, Christina's on the call as well, and I've got a couple other colleagues. We are happy to help you. We want you to help you get your research done. We can't promise that we are able to help everyone, but I will promise that we'll at least put you in the right direction, and hopefully you'll be able to use the OSPool as part of that. Feel free to reach out, and then standard disclaimer, we're funded by the NSF, but our opinions and views do not reflect that of the National Science Foundation. All right.
Awesome. That was fantastic, Andrew and Christina. Thank you both so much for your time. And I know an hour is not a lot of time, but we greatly appreciate you all presenting to our community. And I think based on what I saw, I think the community would definitely want you all to come back and present more, in the future as well. So thank you again so much for your presentation, Andrew. Really
Yeah.
appreciate it.